Good morning everyone. My name is PalaniVel M from CACB, register number 24105-107. Today I am going to present my AI Immersion series, activity C28, title Inside Large Language Models. In this presentation, I am going to explain how an LLM processes our questions, how transformers, tokens, embedding and attention work, and finally I will show a small hands-on comparisons of DeepSeek, Kimi and Qwen. So let's understand what actually happens inside an LLM when we enter a prompt. What happens inside an LLM? First, let us understand what large language model is. An LLM is an AI system trained using a very large amount of text data. Its main purpose is to understand patterns in language and generate human-like text. An important point is that the model does not directly understand would like humans do. It covers into input into numbers that the model can process. The basic process is user question, tokenization, embeddings, transformer, self-attention, prediction, generator, answer. For example, if I ask what is 5 plus 7, the model processes the input as tokens, uses it learned representations and attention mechanisms and predicts the answer 12. So LLM is not simple looking up an answer for a database. It generates an response probability based predictions. 3 LLM understand the microscope. For my hands on explorations, I selected 3 different LLM platforms: DeepSeek, Kimi and Qwen. First, DeepSeek. DeepSeek is mainly useful for reasoning, coding and technical problem solving. One of its strengths is its structured approach to technical questions. Second, Kimi. Kimi is known for handling long context and detailed explanations, so it can be useful when working with long documents or extended conversations. Third, Qwen. Qwen provides multilingual capabilities and is also useful for coding and general reasoning. So I select these three because they provide different experience and capabilities. After selecting them, I used the same prompt on all 3 platforms to make a simple hands-on comparison. One prompt, 3 LLMs. Now this is the main practical part of my assignment. I used exactly the same prompt on DeepSeek, Kimi and Qwen. The prompt was: explain how a transformer based large language model processes a user's questions including tokenizations, embeddings, self-attentions and generations of the final answer. Give a simple example. I then compared this output based on a explanation, depth, structure, example quality and overall response style. From my observations, DeepSeek produced a structured and step-by-step style of explanations. Kimi gave a very detailed and tracked response with clearly separated session. Qwen provided a clear and accessible explanations and its response including a concept example. One important observation from this experiment is that the same prompt can produce different response for different LLMs. This can happen becomes different models have difference in this training architecture, alignment, context handling and generations behaviors. So this experiment helped me understanding the LLM platform itself can influence the style and nature of the output. Transformation architecture. Now let us see what happen inside the model. Modern LLMs are mainly based on the transformer architecture. The process starts with the text which is converted into tokens. These tokens are then converted into embeddings which are numerical representations. After that the information passes through multiple transformer layers. One of the most important components is self-attention. Self-attention helps the model identify which tokens are important in the relations to other tokens. Then the feed forward network further processes the representations. Positional information helps the model understanding the order of tokens. Finally, the model produces probabilities for possible next tokens and generates the answer step by step. So basically transformer processes the relationships between token rather than reading the sentence exactly like a human. Tokens, embedding and attention. Now let's look at three important concepts: tokens, embeddings and attentions. First, tokenization means splitting text into smaller unit called tokens. For example, the sentence AI makes learning easily can be divided into words or smaller subwords. Next, these tokens are converted into embeddings. An embedding is basically a numeric vector representations of a token. These vectors helps the model captures semantic relationships and meaning. Finally, we have attention. Attention helps the model identify relationship between different tokens and understand which parts of the context are important. It used three important components called Qwen, query, key and value. These are used to calculate attention, weights and produce a contextual representations. So in simple terms, token represent the input, embeddings represent it numerically, and attention helps the model understand the relationship between the tokens. Prompt engineering. Next is prompt engineering. Prompt engineering means designing our input it in a way that helps the AI produce a more useful output. For example, a weak prompt is simply explain AI. This is a very broad. It does not specify the role, audience, topics or expected format. An improved prompt can specify that the AI should act as a AI instructors, explain the topic to a CSE student, cover specific concepts and provide the answer in the particular structure. This gives the model more context and clear instructions. Some common prompting techniques are zero shoot, few shot, role prompting and structured prompting. So the key idea is better instructions generally help us get more useful and relevant output. Context window and multimodal AI. Now let's move beyond text. First, it is the context window. A context window is the amount of tokenized information that a model can consider at once time. This can include the current prompt, previous conversations and documents. If the input become too large, some older informations may be truncated or unavailable to the model. Large context windows are useful when working the long documents and long conversations. The second concept is multimodal AI. Traditional language models mainly worked with text, but multimodal systems can work with different type of input such as text, image, audio and video. For example, as a student, I can upload a diagram and ask the AI explain it in simple language. So multimodal AI allows AI systems to work with more than just text. Responsible AI. Finally, we need to understand responsible uses of AI. First is verifications. AI can generate incorrect information, so we should always verify important facts. Second is attribution. When we use information from reliable sources, we should acknowledge these sources. Third is academic integrity. AI should help us learn, but it should not replace our own understanding. Fourth is privacy. We should never upload confidential, personal, or industrial information to public AI systems. My overall approach is AI assistant, verify, understand, explain it our own words, city sources. So the goal is not simply to submit an AI generated answer. Key takeaways. To conclude my presentation, I would like to highlight 5 important points. First, LLM process language tracked tokens and numeric representations. Second, transforms use self-attentions to understand contextual relationship. Third, prompt quality can influence and usefulness of AI output. Fourth, my hands-on experiment showed that different LLMs can produce different responses to the exact same prompt. And finally, responsible AI requires verifications, attributions, and human understanding. Tracked this activity, I understand not only how to use LLMs, but also what happened behind the interface when we give a prompt. Thank you for listening, and I am happy to answer any questions.